Today I will talk about image processing. I'm so sure that you have some definition of image processing back in your head. You might know a little bit about image processing. What I try to do today is I will go more deep inside the image processing. You will not see any formula, any calculation. You will not see very difficult part of image processing. So because I try to introduce image processing, so I will show you the beauty of image processing. So you will be turned into working in image processing, and you will see the difficulty by the time that you already start to do the image processing. So let's start with a very simple definition of image processing. The definition that you can find it in any book, in any website, and this is basically from Wikipedia. Image processing means that we have a system, we have an algorithm, which you give an image as an input, and you will get a vector or a matrix as an output. This vector will be a vector of features, like, for instance, you send a face image to the system, and you get the location of eyes, lips, nose. Or it will be another image. For instance, you send an image with a low contrast, and you get an image which has good enhancement and good illumination. Now, these tasks that we can do can be image display and printing. For instance, you have done some implementation on your image, and you want to save it, or you want to show it on the screen. This is image processing. Very simple, but it still is image processing. You can do the editing and manipulation. Paint, Adobe Photoshop, and so many similar programs are doing that. You can do image enhancement. We have nowadays on the cameras, you can enhance the illumination and contrast before you take the picture. We have feature detection. For instance, facial expression recognition. You know that there are some features on the cameras that if you don't smile, it will not take the picture. So it's a feature detection and image compression. We are having the flash memories, and we try to have less amount of file, less amount of byte for an image or for a video in order to carry more image and more video. So image compression and basically video compression is also very important. It's a part of the image processing. Now, in a few slides, we will look at the applications of image processing. It doesn't mean that these are the only application of image processing. I'm just showing some of the most important application of image processing. The first one is in astronomy. We know that astronauts, they take lots of pictures of one planet or one sense, but because they are very high resolution images, so they can capture only one portion of an event. So what happens, they are transmitting lots of images back to the base on the Earth, and then they have to combine them. We have this event on our mobile phones, on our cameras, which is called the panoramic images. You have lots of images, and you have to match them and put them side by side like a jigsaw puzzle to make a bigger picture. Or we are doing, some cooperation with material science. We are modeling the data that they have based on the depth information, based on the heat that they have. Medicine. I'm so sure that you are familiar with MRI. It is one of the biggest applications of image processing, where we are modeling the 2D or 3D image of the brain or the other part of the body. And also biometric and security. And usually when we talk about the biometric and image processing, fingerprint, face, and also iris will come into the mind. But we have so many other features which basically you can use as a biometric features. Another application of image processing is on geoscience and remote sensing. Mapping. They take the pictures of the Earth, and then they try to make a map of those images of the city. And environmental monitoring. It's frequently used in the places that are hot, like south of Europe, and they have jungles. So they are detecting the fire before the fire starts to grow and make it a very big disaster. In agriculture, we can also use it. We can check by using the cameras and image processing tools that whether a fruit is ripe or not, or whether we have any problem with the fruit. We can categorize them based on the color. And also personal photo usage. I'm so sure that you are familiar with the Instagram or so many other things. You want to put a picture on the Facebook, usually you crop it. Or usually you do some enhancement on that one. This is also an application of image processing. Now, let's talk a bit more detailed examples. And the first example that I want to show you is a face detection. Face detection seems very simple. You have a picture of people, and you have to detect their faces. But this algorithm should be very careful because we have different peoples with different race. And usually the face detection algorithms that we have, they are not working with the dark-skinned people very well. Or if they are working with them very well, they are not working with the people who have a lighter skin color. Now, this algorithm, which detects these faces, is called a Viola-Jones algorithm, which is one of the best face detection algorithms in the world. And it almost detects all the faces, no matter what their skin color is. Another one is noise removal. Denoising is also very, very important for many image processing applications, because the images that you get are always noisy, especially if you are talking about the satellite images. We have always some additive noise on the images, so we have to remove them. In order to remove them, we need to filter the images, which means that you have to develop some specific image processing tool. Again, I'm not talking about the details, how you can do this filtering. I want to just give you some idea what image processing is, what you can do if you want to work on image processing. And each of these examples that I show you, although they are solved, but there is still research going on each of these ones. Contrast enhancement. If we have a low contrast image, like the one that you see on your left, we try to enhance it, because sometimes the image that we have, it contains lots of information, but due to the low contrast, we cannot see those information. So we try to enhance it in order to see those hidden information. They are there simply because the difference of the pixel values are not too much. You cannot see them, and you cannot get those information. The other one is edge detection. Edge detection is also very important, especially if you want to do some classifications. Edges are high-frequency components of an image. There are various methods in order to do these edge detections, and this is one of the methods in order to detect the edges in an image. Segmentation. Maybe segmentation is one of the best examples of image processing, because you actually can see what you are getting at the end. For instance, here we have a picture of a person, and we are segmenting out the skin region, the face, and we are removing the hair and the clothes from the image. Segmentation can be done based on the color or based on the pattern and the shape that we have. Another example is watermarking, which nowadays is very important, because now we are using the social network. The most important one is Facebook and Twitter, and people are putting their pictures. And sometimes you are taking a picture, a very nice sense, and you want to be the only person who have the right of using that one. In other words, you want to sell it later. So what they do, they put a mark in it. For instance, here we have a picture of Lena, which is a very famous picture in image processing. And I have my signature, and I'm embedding the signature into the image. And as you can see on the last image, we have my signature inside the image, but the quality of the image is so good. So if someone steals that image from me, and if they are doing some attack, like changing the color, enhancing the illumination, putting some writing on top of that one, still I can get this signature back. So if you can get this signature back, it means that you can go to the court and you can prove that this is your image. So no one can use your image. I mean, this is very important if someone is abusing your images, or someone, you are a very professional photographer and someone is stealing your image and selling it instead of you. There are many more applications, like digital inpainting. You know that we have the picture of our grandparents or the grand-grandparents, and because they are very old, there are lots of lines in them which we cannot see the image very well. There are techniques which we can feel these lines. So old picture can look very similar to the new pictures. It's not painting, it is just filling those blanks. City planning. People are quite using these satellite images in order to plan the city, and in order to analyze where is the growth of the cities going. Is it going towards the north, south, west? And it is very important for civil engineers actually to analyze that one. Region detection. I already gave you an example of that one, segmentation. But sometimes detection of the region is very important. You can find out different patterns that we have in a region, and each pattern can be interpreted and can bring some meaning. Compression. I told you again an example that we always want to have very small space for big information. So always compression is very good. Coding. You are transmitting a video that you have taken through a Viber or WhatsApp to your friend. So how we are coding it, how we are modulating it, it's very important for us and also for people who are doing the communication. And also 3D imaging, reconstructing an image from various images that you are taking by a normal camera in 3D form. Now, what are essential for image processing? Because an image is a 2D or 3D signal, so basically signal processing is very important. So you should have some knowledge of signal processing. Because if you know some knowledge of signal processing, you can apply all those techniques on an image. For instance, if you know what is filtering, if you know what is convolution, you can apply them into the image, and then you can interpret them. You have to know the matrix theory and linear algebra. And the reason is, the image that we see is actually a matrix. So all the matrix, the mathematics behind the matrix, you can apply them on an image. Maybe they are not meaningful, or maybe you can define some meaning on them, like usage of singular value decomposition, which is very known in mathematics, but recently we have started to use them in image processing. And also probability theory and stochastics. Well, the image is not very random. But the system that uses that image usually works with the probability. So knowing probability means you can handle an image and do a process on an image very well. For instance, in the super resolution, we can use the Markov chain, which is very well known in probability theory. Again, if you don't know probability, it doesn't mean that you cannot do image processing. Or if you don't know signal processing, it doesn't mean that you cannot do image processing. But if you know these ones, you can do image processing much faster. Or you can bring some new idea into the image processing. Now, because it is a matrix, so mathematics is important somehow. You should know some knowledge of calculus, some knowledge of linear algebra, probability and statistics, differential equation, differential geometry, like gradient, and harmonic analysis, like Fourier transform, which basically in high school or in the first year of any college, you are getting some information about them. So any university student can start to work on image processing because they know some foundation and fundamental of mathematics, which is required for image processing. Now, relationship between image processing and other fields. Now, we have image analysis and we have computer vision, which in the next slide, you see that they are in line with image processing. And we will see their differences. Image analysis, as the name stands, is it analyzes what is inside an image. Information retrieval is a very good example of that one. And computer vision is actually simulating the human vision. It tries to interpret an image. It tries to do the object recognition. It tries to do the tracking. Now, if we go to the next slide, we can see that image processing is actually a low level of processing of an image. And we have the image analysis in intermediate level, and the high level is computer vision. But when you do a research in image processing, you will see that you are actually doing image processing, image analyzing, and computer vision at the same time. And the reason is because when you want to see and output an application of your image processing or image understanding algorithm, it means that you are doing a computer vision. But in line with that one, there are very important difference between computer vision image processing and computer graphics. Sometimes people are mixing them, but they are totally different. Even in the university, they are different courses. Because the computer graphics basically talks about how we can synthesize an image, how we can model an image. And it happens that while they are doing them, they are using the image processing tools quite a lot. So there are two different things. A person who does the computer vision and image processing, they don't do computer graphic. But the people who are doing computer graphic are using the algorithms which have been developed by image processing researchers. Now, In computer graphic, one of the important things that we have, and we face quite a lot, is called aliasing. Look at these two images. This is a good image which has no aliasing. And here we have aliasing. By aliasing, I mean that, look at the pattern of these two houses. Can you see that we have some curve pattern appearing in here? Or we have some artificial colors added into here? This is called aliasing. We have this aliasing quite a lot. If you are familiar with the TV concepts and TV shows, if you are invited to a talk, they will tell you you should have a shirt or T-shirt with a plain color. Or if it has a square, the square should be big. If it is small, they don't like it. You have to change it. And the reason for that is because it will cause this aliasing, and it is not very good. I have another picture which shows that one quite a lot. Now, what is this aliasing? There are two definitions which I will show it to you. One of them is from signal processing point of view. When we have an analog signal and we want to make it digital, we have to sample it. I'm so sure you are familiar with this. We have to sample. Now, if we are sampling this one with less number of samples, there is a threshold. If we are sampling with less than that threshold, what will happen? We cannot reconstruct the signal back. As you can see, instead of having a sinusoidal signal, what happens? The signal will never go down. It will start to go up. This is called aliasing. As you can see, it's not easy to understand because signal processing means we have to talk with mathematics rather than the human language. Now, in image processing, it's much easier. You have this image, you put it into the computer, and you get this image. This is called aliasing. So it means that the sampling, the number of samples are not good. Now, can you see that here? Look at this. The previous one, without aliasing, this is the actual image. But when you sample it with less number of samples, we are getting this. And this is not good. Of course, there are lots of basic and simple tools which you can use in image processing. For instance, a smoothing, which you can get rid of this aliasing. Now, as you can see, we have two sides of image processing. One of the sides is purely mathematics. So you can be very good in mathematics. You can talk about all mathematical equations, and you still can do image processing. Now, another example. We have something which is called a Laplacian operator, and you might be familiar with the Laplace operator from the mathematics. Now, if we want to do it on an image which is discrete and digitized, in other words, instead of the differential equation, we will have a difference equation. So we can estimate the above equation with what we have below. So this is called a Laplacian operator. Now, in image processing, Laplacian operator means this. You have this image. I am getting the edges of the image, and I add it on top of the image, and I get a sharper image. So the same thing. One of them is very mathematically involved. The other one visually tells you what I mean by Laplacian operator. So as you can see, in image processing, we can use a very smooth language, a very nice tongue, and we can see what we want to do without knowing the mathematics behind it. Or you don't like this, you like the difficult way, you can always go down and express everything with the mathematical equations. So both of them will lead you to the same point, to the same end, but two different interpretations. And this is a beauty of image processing. It doesn't force you, no, you must do mathematics. Or it doesn't force you, no, you must do programming. You can, if you are good in mathematics, you are welcome, you can do it. If you are good in programming, you are welcome, you can do it. Now, another application of image processing is fun. Definitely, fun is one of the motives that made me to work in image processing. This is a picture of me that I took this morning. And as you can see, one thing that I want you to notice is the background is almost the same color. By using a few lines of coding or simple applications such as Photoshop, you can combine these two. This is a picture of New York. And I did it by using MATLAB. And I put New York as my background. So I can put it in the Facebook and say, oh, at New York, feel happy. Or, again, the same picture and the United Nations. And I can put United Nations at my back and I say that on my spare time, I go to United Nations. So these are very fun with the image processing that you can do. People are doing it quite a lot in Instagram. Now, I can tell you that actually image processing is like cosmetics that a lady wears, but you can do it for free if you know how to use it. You can use the Sophia or vintage filter. You can take a picture, you look not very nice and ugly, so you can use it, you make it black and white, you play with the contrast, then you look so smart that everyone will like the image. Or you can make it blurry. You do not look very nice, so you make it blurry, and it's mysterious. And it's image processing. You use a very simple filter. Look, you are laughing, it means you like it. But imagine the person who does it and gets money out of you, 1 cent, in order to make it blur. And also sharpening in order to make you looks very nice, like the previous image. Sharpening means Laplacian operator. Now, why should we do image processing? In our daily life, there are lots of things that we do with our eyes. This means there are lots of things that we can do with the computer vision. He's drinking tea and he's grabbing his cup because he can see where the cup is. So it means that we can develop a system which can look at the cup and can locate it. So a robot arm, basically based on all the information that a computer vision algorithm has provided, can go and grab the cup. So this is very, very important. We have very good vision system, if you're not blind, of course. You have a very good vision system. So it means that we can have a very good computer vision system. It's very tight. It has very tight relationship with many other science. Physicians, we can work with them. Chemists, we can work with them. Psychologists, we can work with them. And I will provide you some examples of all of those. Because a chemist is doing an operation and they observe something. They observe something. It means a camera can observe that thing. A physicist is doing a measurement and reading a value. It means a camera can read the value. So because we are using our eyes quite a lot in the science, it means that an image processing guy can be a good friend with all people of different branches. Not mathematicians, so sure. You can make fun out of that one. And definitely you can make money out of that one. And I know lots of examples of people who are good in image processing, they stop doing the research because they got lots of money out of that one. People who develop in Instagram. People who work with Photoshop and developing a simple, very, very simple filters. Because if you work on image processing, you see that all the filters that we have in Photoshop, they are so simple. And you just laugh. People are paying money for that. And humanity. Yes, image processing helps humanity quite a lot. Because imagine we are doing lots of things with our eyes, and now we have a computer system which does do. So the blind people can use that computer vision in order to have a better feeling of the life. Now, nowadays we are doing this facial expression recognition, and people are now very good in that one. So a person who is blind, by using a camera, can understand whether the people who are surrounding him are happy, are sad, are surprised, so they can have a better interaction. So we can increase the level of communication in a human society better by using this image processing. Now, on continuation of why we have to do image processing is computer vision is so good. You can have it anywhere. On a robot, you can easily see your result. This is very, very good. You know, a mathematician sits on a table. They solve 20 pages of integral. And at the end say, yes, we solved the integral. And they show it to their parents, and they say, so what? But an image processing guy, they take an image, and there are lots of pictures, and automatically they detect their face, and they can show it to their parents without no knowledge, and they say, wow, it detects you. So you can see the output, and this is really brilliant because you know what to compare with. I am writing an algorithm that takes a picture and detects my face. How do I know I am correct? It detects my face. If it doesn't detect, it means it doesn't work. It's not like chemistry. Let's put some sodium and see what happens. Poof, explosion. But what's that? We don't know. Something happened, but we don't know. Am I right? We don't know. Am I right? We don't know, because we are doing it randomly, unless you are following a formula. But here, we know what to compare with. I am doing super resolution. I know what my output should be. A bigger image with a good resolution. So because we are good in vision, it means that I can always visually compare and say that, OK, I am good. Or, no, this method doesn't work because I'm not good. Image processing will lead you to design. And as Steve Jobs said, design is not just what it looks like or what it feels like. Design actually means how it works. Design means we look at our eye and we are designing a camera. This is design. An image processing guy usually has good vision of doing this design. And this is, again, good, because if you do a good design, it means money. Now, I told you that an image processing guy can have interaction with so many scientists in different branches, because image processing is very essential for many works that computer vision do the collaboration with that science. For instance, in the information retrieval means that you have a picture, and it says that inside the picture we have chairs, we have human, we have camera, we have computers. But in order to do that, the image should have very good illumination, should have very good resolution. In other words, image processing is required before we do the information retrieval. So image processing is very good. And I told you, I will show you an example of image processing and psychology. And I can tell you that the psychologists are using computer vision techniques in order to detect whether a person is lying or not. And there are lots of EU projects about that one. And police are now using it. So they are very good. The algorithm almost works properly without any problem. So there is a very good and tight relationship between psychology and image processing. Why psychology and image processing? Because the people who are working on psychology, they are working on the brain. Computer vision and our vision is working with the brain. And the image processing guy is trying to simulate this part. In other words, we need the brain, which means we need a psychologist. And usually an image processing guy looks at things very different. They have different point of view. And I can tell it from my own experiments. Usually, if you are good in image processing, you sit at the side. You look at the people, how they behave, how they use their eyes. If you want to detect something, do we care about the color? Do we care about the pattern? What is important about that? So we will have different point of view. Now, in image processing, another nice thing is we are not scared of being simple. We can be novel and simple. It's not like so many other branches of science that, no, it's too simple. If it is very complex, now we can think about it. It's not like that. We can be complex and complicated, but we can be very simple and be novel. I send almost all of you the email about the apple, and I always tell this example to my students in image processing class, that a simple fruit of creation, a simple apple, have changed the human life 3 times. So you can be simple, but you can be still novel. In image processing, we are also learning this. Sometimes you do not need to create something. You can change the point of view. So when you change your point of view, you can see other things. You know that we are always seeing one side of the moon? No one has seen the other side of the moon? So if we see the other side of the moon, we are getting more information. So sometimes changing the point of view is very important. And in image processing, sometimes we do that. We have the same thing, and we are looking at from different point of view, and it brings new topics of research. Now, I am sharing you some research ideas. I mean, I have these ideas, and there will be some people who definitely will work on that one. And one of them is a slideshow, intelligent slideshow, which use the entropy analysis, content analysis, and also color analysis in order to show the images that you have in your computer. Well, everyone has that slideshow in the computer, but it will also play a music based on the content of the image. If it is a happy image, it plays a happy music. If it is a sad image, it plays a sad music. We can understand the sadness or happiness of an image based on the psychology of the color. This is not very novel, but you can get patent out of that one. You can get money out of that one if you can do a good marketing about it. The other idea is, for instance, slip detection. People are still doing slip detection. They are not very good. It's very important because if we are able to detect the slipness, it means that we will have a safe journey. So many accidents are happening because people suddenly fell into sleep while they are driving. The other one is 3D human movement modeling. I don't know how many of you were here yesterday when we have a visiting professor who was giving us a lecture about humanoid robots. And he was always saying that we are doing a modeling, then the robot is doing that. This modeling can be either done manually or by using cameras and scanning a body movement, we can do the modeling of a human, which means that we can then transfer all these movements into a robot, a humanoid robot. And also medical imaging. MRI is a very good example of that one, which already people are doing it. But we have so many other concepts which have not been touched, like blood cancer classification or brain abnormality detection. They are open topics. Like if you want to work, you can choose any of these topics and you can start to work on that one. Now, there are two things that makes image processing also easy to work. One of them is the power of simulation. Again, let's go to the chemistry, because we know that analysts will not get angry. In the chemistry, you want to do an experiment, then you should have all the acid, all the bases, all the materials, all the things to be ready. You do the experiment, and while your girlfriend calls, you look at the phone, and it's gone. You have to put all the things again, and this means you have to spend lots of time. But in image processing, we don't have that problem, because all the acids, all the base, all the materials are only some codes which you have to write and do the simulation. And if something goes wrong, you can go to the place that you have the mistake and you can modify it. This shows the power of simulation. If the people are doing simulation, they know how good it is when you compare it with the other science. And also the power of your imagination. In image processing, the power of the imagination is very important. So you can always imagine. You imagine something and you simulate and you try to get to that point. And with image processing, you can do that. I tried it quite a lot and I was quite successful in that one. The last thing that I want to talk is not really in line with image processing, but it's in line about how you can be successful in your research. And it is this. Everything that you see around yourself and you call it life, it has been created and made up by people which are definitely not clever or smarter than you. What does it mean? It means that you can create your own research, you can create your own problem, you can solve your own problem, and you can create the things that you imagine and make the people to use it. And when you learn this one, then you will not be the same person. If you learn this one, it means that now you can be a leader of your own research. I hope that you have a nice weekend and enjoy this snow, and thank you for listening. Yeah, any question? No question means good presentation.
I have a question.
Yeah.
I've seen some pictures,
yeah.
Which are some old pictures taken which are black and white, and they are transformed into color.
Yeah, it's called colorization. Yeah.
Yeah, and I have always wondered how it's done, because isn't the black and white picture it loses that information about the.
Yeah. Have you gone to a Photoshop, a shop which does this thing, and then you give a picture of your grandfather and tell them, can you please colorize this? Okay, if you go there, they will ask you this question. What is the hair color of your grandfather? What is the eye color of your grandfather? So basically, when you do the colorization, you define some predefined color. Like the hair is black, the eye is blue. It's not like you give a black and white color and they know, this should be green. It's not like that. And you know Lauren and Hardy? Do you know the comedian Lauren and Hardy? Old comedian, I mean, you're too young. They have old black and white movies, and then they colorized all those movies, and people hate it because they colorize randomly. For instance, they color the Lauren hair to be brown, which was a lie. He was not. He was very, very blonde, like what we have in Laurie's hair, you know. So that one is important. We can do it if we know some preliminary information. Like if I know your color eye, the color of your hair, then I can definitely make the black and white image into a color image. But if I don't know it, it's up to me. I like black hair, so your hair will be black, sorry. Yes?
What are they actually doing when they hide signature into picture?
Okay, there are lots of things that you can do. My latest publication, which is on that one, we are using a very difficult term. We are using something which is called Z-trip transform and wavelet transform and singular value decomposition. And we are laying down the signature into the singular value of the image that we have. In other words, we are making the signature to be robust to the attacks, because if the singular value of this matrix are changed, it means that you have lost the whole image. For instance, you had that image and you are cropping the face. If I crop the face, nothing will be left, so you can use that leftover. So we are going and putting the signature into the important part of the image, in the important bits of the image, so that if someone attacks, in order to kill the signature, you have to kill the whole image. So it will be nonsense. So if you want to know more details, then I have to tell you about the wavelet transform. I don't know if you're familiar with that. We are using discrete wavelet transform. It's one-level discrete wavelet transform. And then we are going to the high frequencies. And for the high frequencies, we are using the chipset transform. And the output of that one, we are applying the singular value decomposition. Then we go to the singular matrix and we embed them. And we get back all the way and we get our image, which has the signature in it. So I don't want to scare you with those terms. Sorry?
It seems complicated enough.
Yeah. No, it's not complicated. Okay, good point. I showed you on the slide that you need to know signal processing and you need to know linear algebra. If you know signal processing, you know that wavelet transfer is the simplest thing in signal processing. Chipset transform is almost simple in signal processing. And singular value decomposition is very easy in matrix theory and algebra. So simple, simple, simple. When you put them together, it will be a new idea. But if you are not familiar with the terms, it might look difficult. But if you are familiar, you say, oh, very simple things together, and it makes a novel method. Yeah. Any other question? Okay, if you have no question, I thank you again for coming here and enjoy your evening. Thank you.